The 30 kilogram block is supported by two springs having the stiffnesses or these K values shown. Determine the unstretched length of each spring after the block is removed. So we are given that our mass of A is equal to 30 kilograms. And they want us to find unstretched length. So I'm going to call those LAB and LAC. Little l, little AB, little LAB, little LAC to talk about the unstretched length of these springs. We can draw our free body diagram by isolating everything at point A. We're just looking at point A. We have a force AB coming up from A to B. And then we have a force here, FAC. And these are at angles I'm going to call theta here and phi here. And then we have our weight coming down of 30 times 9.8 to make it into newtons. So we can define theta looking at our dimensions given. So theta here, this angle, theta is equal to the angle whose tangent is opposite, so 0.5 over the adjacent, opposite over the adjacent. And so that angle is 51.34 degrees. And then phi, we're defining as this one. And so the angle whose tangent is the opposite, again, is 0.5 here, same as here, over the adjacent now for this one is 0.6. So this angle is 39.8 degrees. All right, setting up my equations of equilibrium. Some of the forces in the x direction, I have FAB times the cosine of 51.34 degrees minus FAC times the cosine of 39.8 degrees is equal to 0. FAB cosine of 51.34, then I can move this part over to this component over to the right. So I have FAC cosine of 39.8, and then these are scalar. Multiply that out, I get FAB is equal to 1.23 FAC. And I'm going to call that my equation 1. Then I can do the sum of the forces in the y direction. My weight is negative 30 times 9.8. And then I have the FAB going in the positive direction, FAB and its angle, which will be sine of 51.34 to get that y component, plus FAC sine of 39.8 for the y component of FAC, and set that equal to 0. I'm going to stick FAB. I have FAB here, so I'm going to put 1.23 at FAC in anywhere I see FAB. So I have 1.23 FAC times the sine of 51.34 plus FAC sine of 39.8 is equal to, and I gotta get this scalar over here, 294. Multiplying these out, I have 0.96 FAC plus 0.64 FAC is equal to 294. Combining these two terms, I have 1.6 FAC is equal to 294, and FAC is equal to 183.75 newtons. And then if I put this into equation 1 up here, I get that FAB is equal to 226 newtons. So these are two interim values that I need that tell me the force that is seen on the springs, but that doesn't answer the question of what are the unstretched lengths. All right, so to actually find those unstretched lengths, I have to understand and know that the force on a spring is equal to the spring constant times the stretch. So let's first find the stretch of each of these springs. I found previously that the force FAC, I'm going to write these up here, FAC is equal to 183.75 newtons, and FAB is equal to 226 newtons. So I know the force here and the force here. So knowing what I know, FAC is equal to KAC times the stretch of AC. So I can put in 183.75 is equal to 1.5 times 10 to the third because it's in kilonewtons. Making sure I have that 10 to the third because of that kilo times SAC. Solving this then for SAC, I get 0.1226 meters of stretch for the spring AC. Similarly, I can do FAB is equal to KAB times the stretch of AB. I have then 226 newtons is equal to my spring constant of K, 1.2 times 10 to the third. Again, remembering that kilonewton times SAB. Solving for SAB, I have 0.1883 meters. But I'm not done yet. That's just finding the stretch. It's asking for the unstretched length. So we're going to do a little geometry to find the length. The length here is going to be the hypotenuse of our triangle, right? The Pythagorean. So LAB, the length of AB, is equal to the square root of 0.5 squared plus 0.4 squared, or 0.64 meters, and the length of AC is then equal to the square root of 0.5 squared plus 0.6 squared, and that is 1.78 meters. Now the final is to then find the unstretched length. The unstretched length, I defined as L, is going to be the overall length minus my stretch. Sorry, not AB. So that's just the general form, the overall length minus my stretch. So my LAB, my little LAB will be big LAB minus my stretch of AB, or 0.64 minus 0.1883, which is equal to 0.452 meters. And then so that's one of my answers. And then L of AC will be my big LAC minus my stretch AC, which is 0.78 minus 0.1226. And I've stopped being able to write. And the answer is 0.658.